This is the last of a series of videos on creating a string utilities file. This is a pretty powerful tool, but it's actually expandable. You can add more functions to it if you need further string utility operations. Let's jump right into it here. We're going to take a look at where we left off in step 5. And again, if you've done a good job in step 5 and you took your time figuring out what you wanted and what needed to happen and so on, this step 6 process is just easy. You just fill in blanks. For example, your initialization, I need a difference and an index equals 0. I might not know these as I'm writing the code, and I might have to come back and do this, but again, it's never hard. I'm going to loop to the end of the shortest string, which means I have to check both strings for the null character, watch to see if either one of them ends up, and I run the overrun protection, which I do in all of the functions that do any looping across strings. Difference in characters is easy. Take one character from one string. We're looking left compared to right, remembering what we have here. And I'm going to subtract the right from the left. If there is a difference, in other words, if it's not 0, okay, I'm going to return that difference. And that will mean I found a difference. And I will also know by the positive or negative quantity that it is greater than or less than. In the course of iterating across this, I'm going to have to increment the index. I'll end the loop there. We've got that. And then I will go ahead. And if you've come through here for whatever string, one might, for example, maybe one of them is Will and the other is William. So it's shut down at the end of Will, but there's still a difference. William is longer and therefore is greater. So that's where we will return a get string length and down here. Could have done the get string length up here, but the truth of the matter is more oftentimes it's going to end inside this loop, so I don't need to call the get string length. If it comes to pass, I follow all the way through it, a special case of equal, then in fact, or nearly equal, then I will use these guys and use that. So it's an efficiency thing there. Having done that, I can take away the return 0, and we've got our code ready to go. Now, having done this, I am going to compile this and make sure that I've written good code. Now, remembering that each and every one of these functions that needs a return has it in there. So there is no reason for this particular program to have any warnings or errors about trying to return from non-void or not returning from non-void or whatever. It should always compile clean. If it doesn't, fix it now. One error will turn into 50. 2 or 3 errors will turn into 100. You got to make sure that you've got to keep it compiling so you don't consume that time. We'll try this one right here, and sure enough, we're in good shape there. So I think we can move on with that. And for the concatenate string, remember that there's a possibility the user might put the same string at the source as well as at the destination. Maybe they're trying to just create a long string made of duplicate things, but we want to protect that because we might be changing the destination string in the process here, and which might also change the source string. So we're going to duplicate the source string is what we're going to do. All right, so we come in here, we're going to set the destination index here, and that's just going to get us started where to put that. We need to get the string length so we can make a copy of it. We need to make a temporary string pointer to be the copy, and then we've got one other variable we need to make. Now what we will do here is first of all we'll create something that is the size of that source string length plus 1 for the null character, and then we will copy it. So now we're no longer going to be messing with the source string, we're only going to be messing with the temp string. So we come in here, we loop to the end of that source string, we're using the temp string there, but source index, and protecting it. We assign the characters across from the temp string to the dest string, update the indices, and then set that temporary destination string so it's always a legal C string with every iteration here. Last but not least, we're going to free that memory so we don't have a memory leak in our program. We have created a string here. We've got rid of it here. Our destination string is the same here. It's done. And now if this was duplicated, the source string is the same now as well, but we didn't do any harm during the process here. So that is our concatenate string. The copy string also has a potential for aliasing, but if they are the same, there is no reason to copy them. So we're going to do a very simple check to see if this pointer is equal to this pointer, which means the two strings are pointing at the same thing. So we're going to keep that simple on that. We'll initialize our index here. Here's where we check to see if the two pointers are the same. Remember, we're not looking at data here. We're actually looking, is this the same pointer as the other one? And then we're going to loop across the source string here till it gets to null character and limit the iterations here. Assign the characters, update the index, and then again complete that C-style string so that at all times it's complete after every iteration. We don't have any dynamic memory to deal with here. We don't have to do any freeing. This is about all there is to this right here. But this does in fact copy our string, and that takes care of this. Find substring is a little bit more complicated than some of the others, but again, once you've done step 5 and you really have worked through step 5, put it to paper and made sure that it does what you want it to do. Again, the coding part is easy. Let's put this thing together here. We're going to start with a test string length using get string length on that. We're going to need that for getting our way through test string here. We're going to initialize that master index to 0, which is where we're going to start here. And then we're going to initialize a couple of other variables, a search index and the internal index. Now we're going to loop across that test string, put our block in there. Inside of that, we'll set the internal loop index to the current test string index. Now that's just going to simply say, all right, we're ready to work inside of that. I don't want to change the master index, but I'm going to start here and see how far I can go. I'm going to set the internal search index to 0. Okay, now this is the outer loop that's going to go across the entire string. Now we're getting to the inner loop that's simply going to say, hey, I found a character. I found a C in this one and a C in that one. I'm going to start another loop and see if I can find the end of the string, and the characters are all the same throughout that. So I'll put that loop together. I'm starting here with the internal index is less than or equal to, and there's a reason that less than or equal to, it looks for the end, that null character in there. So usually you'd go up to the less than. All right, and then I look for, as long as the characters are the same going throughout, we're going to be okay. Now, what I'll do from there is I'll say, okay, update these guys. I found the first character on my way in, and then I'm going to check to see if we're at the end of that substring. If I found the search substring, the one we're searching with, if he's to his end, no matter where I am in the larger string, I found the substring. And I'm going to return that beginning location, which is actually the master index, because I never changed that. I had to hang on to that so I could send it back. Having done that, inside the larger loop, the master index does have to be updated to go across the larger string there. And then I will return the substring not found, which replaces that return 0 temporary substring. Okay, and that means if I got through here and I was not able to find it within this inner loop, then I get through the outer loop, I've got to return the substring not found. Let's go on to the get string constrained. Our get string constrained has a lot of constraints, but that makes it completely as adaptable as it can be, so we can use it by itself if we want to, a little bit more complicated, or we can create derived functions from it, which is in fact what we do. Start with initializing the variables. We're going to set the end character to EOF. EOF is end of file. It's actually -1, but it doesn't matter. EOF is all we need to know. And that is in my standard constants file, so that we know that's already included in this file and can be accessed. We'll initialize that output string. The captured string, we're going to set it to null character. So we're going to say the index is 0. A null character at the very first element is an empty string. We're going to capture the very first value in the stream. This is a priming thing again. Grab that very first one in the in stream. Now the in stream will commonly be an actual file pointer that you're going to use. But for testing purposes, if you recall in step 4, we actually used stdin, which looks like, well, it is an in stream. It's actually an input stream, but it's not actually a file operation, even though it's actually treated that way. Okay, we're going to clear the non-printable or space if needed. So the first thing we're going to do is check, hey, we're not at the end of the file. If that's the case, and we say clear leading non-printable and this, and then we're going to say if the clear leading non-printable Boolean is set, we'll check for the fact that this is less than space. If the clear leading space is set, then we'll check for equals space. Now this is an OR situation, so the loop will run for either one of these, either clear leading non-printable or clear leading space. Once we get in there, the only thing we have to do is grab the next character until we're there. We end that loop right there. At coming out of this clearing of the leading spaces or non-printables, we need to take a look here and see if we did hit the end of the file. If we did, we're going to have to return a failed operation, which is easy. Okay, now we're going to go after the input. So we'll loop across here. Now this loop has many pieces here. We'll talk our way through it. First of all, it's not to the end of the file, and we haven't blown up our string. We haven't gone past whatever we want to go past here. Second of all, we're either going to stop at non-printable. If that's set to true, then we will watch for everything is greater than or equal to that. But if it's not, then this loop will fail. Or if the stop at non-printable is actually set to false, then in fact this first one is negated here and the second one takes over. So either one of these can make it keep going. I see either alternative for stop at non-printable. Finally, we're going to check for if it's looking for the delimiter. Now the delimiter can be set to a dummy if we're actually watching for non-printable, and that dummy will not be found in text here. Put in the end of our block here. So again, I broke this out for readability for me as well as anybody else that looks at the code. I know exactly what my logic looks like for all of these. This is very worthwhile doing if you have a loop that gets a little complicated like this. I'm going to stick that character in the string. I have proven that it passes all the tests it needs to pass here, so I can now put it in there. I'm going to increment that array index. I'm going to set that null character for safety so that I keep the end of my string always there. And then I'm going to go get another one and come back and try it again with the loop. Once that's done right here, we can return the successful operation. And at that point, we can take out the temporary stub return. So a little bit complicated, but if you spent the time in step 5, step 6 really is as fast as what I just did, just typing it up and following your own instructions. Let's go ahead and go on to get string length. I'm just going to show that. We already did this one. So you've already seen it. You've seen the code. You've seen the step 5 and 6. Previously, you saw this as a step 1, 2, and 3. And so you've got lots of history on that. Let's get on to get string to delimiter, which actually is going to be really easy because get string to delimiter is going to have the file in stream. It's got to have something it's looking at. It's going to be given a delimiter, and it's going to be given a string to put the data in that's going to capture. So all I'm going to do is call that function get string constrained, and I identify each one of these parameters specifically to handle the delimiter condition. But this one I am arbitrarily deciding will also stop at non-printable, will also clear leading spaces, and will also clear leading non-printables. I'm arbitrarily deciding that, but again, you can write your own functions that just use this engine way easier. Same story for to line in. This is easy. Pass in the in-stream connection and pass out the captured string here. And again, in-stream to the function, engine function. I'm going to clear leading non-printables, clear leading spaces. I'm going to stop at non-printables, but I'm putting in the non-printable character so I don't accidentally stop at the wrong delimiter there. And then I'm going to do the captured string. So this is going to do what I want it to do, take me to the end of the string line. Okay, let's get into substring. And in our get substring, we're going to capture a string within a larger string here, part of it, starting at a given index, end index, inclusive. Not too big a deal, but because we're going to create a destination string, and because somebody could have the same string in both of these parameters, there's a potential for aliasing, so we will deal with that. We'll jump right in here. We're going to get the length of the source string so we can make a copy of it here. We're going to set the destination index, the new string, to 0. We will set the source index to our given start index. That's where we're going to begin. And then we'll create that pointer for the temporary string. But we're not creating the temporary string until we know we're ready to use it. And for that situation, we're going to check and make sure that the user has not put in a request for something, a start index of less than 0, a start index of index or greater. And by the way, this goes up to less than or equal to index, so it'd be greater than index because these are inclusive. and then also not off the end of the source string length. So having done that, then we can go ahead and we can make that string the size of source string length plus 1 for the null character. We can copy it from the source string into the temp string, so we can now use that and not bother the source string anymore. Won't have any problem with aliasing. We'll loop across, again, inclusive source index to the end index here. And good old assigning things here, we'll put that from the temp stir into the dest stir, increment both indices because they're different, and then we'll always make sure that that dest stir is always a legal C-style string after every iteration. Last but not least, we're going to do that free operation inside the if statement, by the way. We don't want to try to do it outside if we skipped over it somewhere, because freeing an empty string or freeing something that hasn't been malloced will cause a system crash. So we have that set up there inside the if statement, and then we'll be done with that. So really not a terribly complicated one, especially given the ones you've already done. It's really kind of repetitious in some places here. But we did have to do the situation where we had to handle the potential for somebody using the same pointer, the same string in both the destination and the source. And so that was potential for aliasing. So we covered that up here and handled it. So that should take care of get substring. For our set string to lowercase here, we need to start filling in code, but that's what's really nice about this process. It really is just filling things in. In our data here, the get string length operation here is going to be putting that in there. We'll set that, and we're going to need that in a minute. We will create a temp string pointer, create an index here. Then we need to create that source string. We're going to make a copy of it here. So we'll start a temp string right here with that size, plus 1 for the null character. Copy the data into there. Then we'll loop across that guy, and we'll temp string there as long as doesn't have a null character and it's not over the limit. Then we'll assign the data value, and we will correct it to lowercase only if it happened to be uppercase. Increment the index, and then again make sure that dest stir is always a complete C string. And then last but not least, we'll go ahead and free that memory so that we don't have a memory leak here. We'll make sure we use this to make a string, and then we got rid of it within the scope of this particular function. So that should take care of that. Set stir to lowercase is really not difficult, especially since you did your step 5 part of this. So we'll wrap that one up. Last here is our to lowercase function. This is pretty straightforward. We need to check for an uppercase letter. Check for that, greater than or equal to capital A, less than or equal to capital Z. And now this is a little bit of an algorithmic problem here. It's pretty simple though. The distance between, say, capital C and capital A is 2. Capital C minus capital A would be 2, and you add that to lowercase a plus 2 is lowercase c. So that's how you convert a capital letter to a lowercase letter. Then once you're done with that, you're going to head and return that test character there. We can take away our temporary subreturn. Understand here that if this fails, then it's going to return the unchanged test character. And that's about it for that. That's pretty much it for step 6 here. We fill in blanks is what we do for our code. That's all we have to do, and it's pretty straightforward as long as you've thought your way through all the problems that you're working through when you do your step 5. And that is critical to think about those things in advance. So we will go ahead and wrap this video up at this point.